Welcome to the lecture series on fluid power systems. So in this lecture video, we'll see the basic introduction to fluid power automation, where pneumatics and hydraulics are being used in the industries. So in industries, probably for automation, we'll go for pneumatics and hydraulics appropriately for the particular task. So we'll start with basic introduction to automation in this lecture series. So first we'll start with why automation is required for any industries. So based on the 4Ds, we'll go for the automation. So the first one is the dirty task. Probably whenever we go for any industrial applications with the dirty task, we'll go for automation. Then if any task has to be done repetitively in the industries where the dull kind of work is there, we'll go for automation. Then the third one is the dangerous one, where people feel dangerous to work in a particular environment, we'll go for automation. Then last one is difficulty. If the people find it difficulty to do any work, they will go for automation. So based on these four Ds, will go for automation. So based on these 4Ds, so the industries prefer to go for automation in the industries. So not only in industries, any social environment also will go for automation. So based on dirty, dull, dangerous, and difficulty task. So apart from that, we have a 5D, that is deadlines or target to meet in the industries. So the industries will go for the automation. Apart from that, there are some reasons where the automation is preferred in industries, like higher production rates, increased productivity for the particular application, then reduced factory lead times, more efficient use of materials, as well as quality and improved safety aspects. Similarly, if the labors required for a shorter work weeks, we can go for the automation. Then apart from that, the fluid power automation probably consists of the pneumatics and hydraulics, where we'll prefer to go for semi automation or full automation in industries. So before that, we'll see the basic introduction to fluid power systems. So if you take any fluid, a fluid is a liquid or gas that probably flows or continuously deforms under the tangential force, like a blood flowing in a vein, or a honey, which is a thicker fluid, or helium gas, or air or water, whichever is flowing in the particular medium, say pipeline or any tubes. Then for the particular application, like a hydraulic lifting jack, we will go for hydraulics. Then in agriculture application, we'll prefer tractors for doing the task probably related to the irrigation, as well as for the uh, particular task that is required in the agriculture field. Apart from that, whenever we want to do some material handling task, we will go for dumper trucks, where the materials are moved from one place to another place. Similarly, we have the industrial task, like modifying the components using hydraulic press. We'll go for the pressing operations, where the hydraulic press is being used. So apart from this, we have the other applications, like the lifting of any material to a larger height, will go for a hydraulic lifting platform. Similarly, transfer of material from one location to another location will go for a hydraulic stabilizing system, along with the lifting system used in the particular application. So next, in case of fluid power systems using pneumatics, we'll go for tightening of any tire using a pneumatic torque wrench, then automatic painting using spray painting gun, then pneumatic jackhammer for doing some kind of a patchwork in the roadways, then some filling machines, dental drills, as well as the tire filling systems, where we'll use the pneumatic systems. So like this, in fluid power applications, we'll go for using both hydraulics and pneumatics based on the task that is going to be performed. Next is the basic definition of fluid power, in which the fluid power is the technology that deals with three things. One is the generation of power, control of power, and transmission of power. So in generation of power, probably for hydraulics, will prefer hydraulic pumps. For pneumatics, will prefer compressors. Then in case of control of power, we have three control components, namely direction control valves, flow control valves, and pressure control valves. For transmission of power, probably will use some fluid mediums, like hydraulic will go for steel tubes or steel pipes. Then in case of pneumatics, we'll go for polyurethane tubes or polyurethane pipes. Then in case of pneumatics, we'll prefer compressed air that is being passed on to the tubes. In case of hydraulics, we'll use either water or any commercial liquids or commercial oils being used in the system. Then for fluid power, probably it is being used to do some activities like pushing pulling, regulating some operations, driving virtually any machines in the modern industry. Then coming to pneumatics and hydraulics, a lot of industrial tasks as well as the commercial places, the both hydraulics and pneumatics are being used. We can see with some applications in this video. So in this we can see that some kind of tasks are being done with the help of hydraulic as well as pneumatic systems.
Fluid
For
pump,
heavy applications,
hydraulics, and
hydraulics are
pneumatics
being used.
is a technology that's been used for hundreds of years in thousands of applications. In construction, agriculture, aerospace, automation, entertainment, robotics. Fluid power equals powerful and controlled motion. Through groundbreaking research and integration with electronics and computer controls, fluid power is ready to.
So like mentioned, the hydraulics probably used in agriculture, then you can go for robotics, then in the space, aerospace applications, then earth moving equipments, we can go for hydraulics, where the high payload as well as heavy torque and pressure is required. In case of pneumatics, probably we'll go for lighter and medium load applications, where pneumatics are being used.
Radically reshape our world. For example, the strength and precision of fluid power is used in green energy applications to adjust the position of solar panels and windmills to capture the maximum energy from the sun and wind. Fluid power is even used to store and redirect.
Like shown in the windmill applications, we can have accumulators probably used for the power generating source, where it can store the energy and it can be used whenever the windmill is not operating. So accumulators along with the power generating source, we can have the continuous power production happening in the windmill application. So like this, we can have lot of places where the hydraulics or pneumatics are being used for the regenerative power source as well as for the other applications.
Energy from the rocking motion of the sea, and hydraulic hybrid vehicles hold the potential to dramatically reduce our dependence on traditional sources of fuel. This proven and inexpensive technology provides better performance and is more eco-friendly than electric hybrids. You can be part of this future. The fluid power industry is looking for forward-thinking.
Then similarly in automobile applications, we can have the accumulators probably used in the hybrid vehicles, where we can have a energy saving as well as for the higher fuel consumption, as well as the power production will be get enhanced, so that we can have a higher mileage probably obtained in the commercial vehicles. So with this, we'll move on to the basics of law that is governing the hydraulics and pneumatics, which is Pascal's law. So in 16th century, Pascal invented this Pascal's law, where it defines pressure exerted by a confined fluid acts undiminished equally in all directions. So the basic unit is given based on the invention by Blaise Pascal, which is Pascal. After that, the other units are derived like bar and psi. Then uh,
The purpose
we can have the other definitions for the Pascal's law, which is transmitted undiminished in all directions, and it is also acting equal force on equal areas. Probably the force is acting at right angles to the wall, right? In case of Pascal's law, it is probably used to a confined fluid that is transmitting power or either modifying motion, or it is multiplying the force. Then coming to the Pascal's law, there is a three-way relationship exists between the pressure, force, and area. The pressure is equal to force by area. That can be also modified, such as force is equal to pressure multiplied by area, or area is equal to force by pressure. Ultimately, we can find out which is the unknown for the calculation of either force or pressure or area in the fluid power applications. Then coming to the Pascal's law, we can solve some simple problems using the Pascal's law formula, either calculating the force or you can calculate the pressure applied over the piston. So in this first problem, we can see that pressure is given, which is 2000 Pascal. Then the area is given, which is 0.1 meter square. Our objective is to calculate the force applied on the piston. So which easily we can calculate force is equal to, based on the previous formula, pressure multiplied by area. Then second problem, we can have the two pistons there, which have a diameter of 60 and 5 centimeter. So in this, the force exerted on the larger piston is given. So for this, we have to calculate the force exerted on the smaller piston. So this again we can use the Pascal's law formula to calculate the force exerted on the smaller piston. So this is what the solution for the problem 1. So we know the pressure is known and area is known. So we can easily calculate the force applied on the particular piston, which is 200 newtons. For the second problem, we have two pistons. One is smaller and another one is larger. So we have to calculate the area specifically for the smaller piston as well as for the larger piston. After that, we can have the formula A1 F1 is equal to A2 F2. In this, three parameters are known, that is area of larger piston and smaller piston are known, and F1 is known. So substituting these three, we can calculate the force exerted on the another piston, which is uh, 70 sorry 15 newton. Then the force is 7200 newton required to lift the piston. So like this, using the Pascal's law, we can estimate the force values or area or even the pressure values required for the particular application. Then similarly, in the application of Pascal's law, you can find it in the various places like hydraulic jack, where with minimum force you can lift a larger weights, like lifting of a car or any platform. If you want to do some maintenance activity, we can use the hydraulic jacks. Similarly, we can find the Pascal's law used in the Brahma's press, where hydraulic leverage we can lift the huge weight with application of smaller force. Similarly, in line to that hydraulic leverage, we have the mechanical leverage, where we have these seesaw application, where we can shift the center point so that we can lift a 100 kg weight using a 10 kg on the other end. Then similarly, in the industrial applications or commercial places, probably the hydraulic pumps used in service stations working on the principle of Pascal's law for lifting a 1 ton or 2 ton of weight easily using the hydraulic method. So this is what the principle followed in the hydraulic service stations for lifting the car using a smaller force, probably the energy equation as well as the Pascal's law is being used here for calculation of the force applied on the car. Then coming to the units of pressure, probably, so you can have the basic unit as Pascal. We can derive the other units like bar, then kilogram per centimeter square, or you can have the pounds per square inch easily converted, because every country following different units in their own standards. In that case, we need a conversion from one unit, that is basic unit, to other units. So for that, we need these conversion factors probably used. Then coming to the hydraulics, probably we can classify it as two things. One is hydrostatics, another one is hydrodynamics. So probably you can have the hydraulics, or probably it is derived with the word hydro means water, as well as olus means pipe. Then coming to the hydrostatics is following the same Pascal's law principle, where we can have A1 sorry pressure is equal to force by area. So we can easily calculate the force applied on the piston. Probably this principle is what being used in the hydraulic jacks. Then coming to the another law that is being used in the hydraulic application, that is law of conservation of energy, where the work done is the force multiplied by d. The same we can employ it in the hydraulic application also, which means the energy can neither be created nor destroyed. What is gained by the force is sacrificed in the distance moved. The same used in the hydraulic cylinders as well as in the pneumatic cylinders. Then coming to the hydrodynamics, where probably you can find the hydrodynamics used in the turbines, where the nozzle of a water jet is being hitting on the turbine blades, where the turbine is rotating, and the same rotation is converted to the electrical energy using the alternators. Probably find it in the all power stations where the electricity is being generated. Uh, so hydraulics, we can have this classification, hydrostatics and dynamics. Then coming to the history behind the fluid power, probably Pascal put forth this principle in the 17th century. Then in 18th century, after the first press was manufactured, so we can have the fluid power used in the cranes, presses, winches, extruding machines, and shearing machines and riveting machines, even before the electrical power was developed. So hydraulics came into practice even before the electricity is being used. Then in the modern era of 19th century, during the World War, So we can have the hydraulics being used for elevating and controlling guns in the battleship Virginia. Then in World War II, the other aspects of aviation and aerospace industry, lot of modern day hydraulics and pneumatics are being used in the weapons. Then coming to the need for fluid power, why we have to use fluid power. So compared to the mechanical, electrical, we can have the multiplication and variation of force is there for the fluid power applications. Then it can be easily and accurately controllable. Then we can have a high power to low weight ratio. Then we can have a constant force and torque we can obtain. Then pneumatics, probably it is safer to use in hazardous environment. This is the reason why we use fluid power. Then a good example to see a hydraulic in the day-to-day places is the earth moving equipment, where we can have the hydraulics are probably used on. So for example, in this the earth moving equipment, where it is used for digging, then transferring of material from one place to another place, we can have the hydraulic cylinder used in the various uh, places for actuating the bucket. So we can have some around 4 cylinders like boom cylinder, arm cylinder, and bucket cylinder are being used, in which all these cylinders are controlled by a hydraulic fluid which is operated by the hydraulic pump. So along with that, this vehicle will move on various areas or probably different locations, and it can be navigating to achieve the required task. Then coming to the other applications like hydraulics, we can find it in the disc brakes. So we can have two-wheelers and four-wheelers are fitted with hydraulic disc brakes. So where we can easily control the vehicle and also effectively apply the brakes. Compared to the drum brakes, we can have the efficiency more in the hydraulic disc brakes. Then coming to the industrial applications, we can have the injection molding machine, where hydraulic clamping system is being used. So we can effectively clamp the molds so that we can carry out the injection molding process in the industry. Then similarly, we can find the hydraulics being used in various sectors like mobile, industrial, and aerospace, where we can find the hydraulics probably used for construction application, agricultural application, marine, and defense. Similarly, in industrial applications, we can find machine tools and the industrial automation. So based on the power requirement, we can have the hydraulics being used probably in the commercial aircrafts, military aircrafts, and the other related equipments. For example, in the aerospace, we can have the hydraulics probably used in the landing gears. So we can have the specific application being find out, and we can use the hydraulics and pneumatics accordingly. Then here you can see in this picture, probably you can see that hydraulics probably used for high load or heavy load applications like tree cutting, then transporting of trees that are doing some maintenance activity in the buildings. We can have these cranes, tree cutting systems are being used, in which the hydraulics are being applied. Then coming to the low and medium applications, where we can find pneumatics are being used like bottle filling applications, or cookie transporting or cookie packaging applications, or bottle filling applications, we can find the pneumatics. Then differences, probably it is purely based on the forces requirement in case of hydraulics and pneumatics. So hydraulics probably used for earth moving, heavy cutting and pressing and clamping applications, whereas pneumatics probably used for clamping and processing applications. Then coming to the force or the load aspects, hydraulics probably used for high load, high force applications. Pneumatics probably used for light load and light moving operations, where the system is a compact and a lesser system. Then coming to the advantages and disadvantages aspect of fluid power. So we have a lot of advantages when we go for fluid power compared to mechanical and electrical. So in fluid power, we don't have the mechanical linkages, so it will be easier to do the power transmission over long distance. Then it can be easily, accurately controllable, reversibly, and as well as you can infinitely vary the speed and load. Then you can have a accurate position control for linear and rotary elements in both hydraulics and pneumatics. Then it is a compact system with low power to weight ratio. Then we can have a self lubricating and self cooling property that the fluid power. Then there will be some small disadvantages associated with the fluid power, like some contamination may happen in oils, fluid leakage may happen, that has to be controlled. Then fire hazards, if in case we are using a flammable hydraulic fluids. Then we can go for some filtration process obviously required in hydraulics. Then in case if the pressure is very high, the flow lines can burst, it can lead to the resulting the injury to the human beings because of high speed oil jet or flying piece of metal. So that has to be it has to be controlled with proper safety and other systems implemented along with the main components. Then summary of advantages and disadvantages. So advantages, probably we can have flexibility, multiplication of force, simplicity, compact economy and safety. Whereas disadvantages probably associated with the efficiency of the system, because of the loss of pressure due to leakage, efficiency will be little dropped. Then cleanliness associated with the hydraulics has to be improved on. So these are this summary of advantages and disadvantages. So then coming to the hydraulics versus pneumatics, it's all based on the system being used. In case of hydraulics, we'll go for a power pack where it consists of a tank, relief valve, a pump with motor. Then in case of pneumatics, we'll go with the air compressors. Then we have an air storage tank. Then the other components are similar to that, so that we can use based on the size. For example, the cylinders are look like for a hydraulic or pneumatic application. Then similarly, piping systems, steels and plastic pipings are probably used in the hydraulics, whereas polyurethane tubes are being used in the pneumatics. So this is what the final difference between hydraulic system and the pneumatic system. So in case of hydraulic system, it is incompressible fluid. In case of pneumatic system, it is compressed air. So oil is incompressible and air is compressible. So in case of hydraulic system, it is governed by Bernoulli's equation and other fluid flow laws, whereas in case of pneumatic system, it is governed by the general gas laws such as Boyle's law, Charles law, and the Gay-Lussac's law. Whereas for both hydraulic systems and pneumatic systems, it is commonly governed by the Pascal's law, where the pressure is equal to force by area. So with this final comparison between hydraulic and pneumatic system, I conclude the basic introduction to fluid power systems. So for hydraulic system, the pressure maximum we can go up to 700 bar. For pneumatic system, we can have the pressure maximum of 10 bar. Then in case of the application wise, it is heavier in weight hydraulics. Then pneumatics, it is lighter in weight. Probably the hydraulic systems are unsafe because of fire hazards, whereas pneumatic system is free from fire hazards. Then probably the hydraulic system leakage, the lubrication is always a difficult and challenging one, whereas in pneumatics there is no such problems there. Then we can easily operate the system. Then in case of hydraulics, probably we have to provide some sensors or some kind of a safety valves to control, since it is a closed system. Whereas in pneumatics, it is an open system, not much the safety aspects we are concerned of. So with this, I conclude my the first series lecture on fluid power systems. Thank you.